So this video shows you a little bit more a reminder of how we're testing a vector force equation for conservation. In other words, is a particular vector force conservative or not conservative? And one of the things that we have in these cases is that a conservative force has no curl. It doesn't curl back in on itself. Now, mathematically, we write that this way in terms of being able to show that we've got a overall curl of 0. So this is a particular vector calculus formula, which you can look at by writing out the determinant of this matrix. Or if we actually go through and do the multiplication, we can write it out as this series of terms. So we're taking the individual components of the force. And just as a reminder, a vector force is going to have some x component of the force in the i-hat direction, plus some y component of the force in the j-hat direction, and some z component of the force in the k-hat direction. So when we plug in those force components and then we take the derivatives, if that curl is equal to 0, then it's a conservative force. If any single one of the terms in there, if that curl is not equal to 0, then it's non-conservative. So to be conservative, the x, the y, and the z terms of the curl have to be equal to 0. If any one of those three, or all of those three, is not 0, then it's definitely non-conservative.